Hello guys, let's work on binary operations today. And today's videos we are going to be handling the question that you can see on your screen. And this question says that the binary operation star is defined over the set S equals to 1, 2, 3, 4 as x star y equals to x power y modulo 5. We should copy and complete the operation table below for S star. And B says that we should give a reason why S star does not form a group. We should assume this operation is associative. So guys, before we handle these questions, we need to know what modulo actually is, meaning that modulo actually means that we are concentrated on the remainder. At any time we divide the value of that operation by 5, we should take the remainder and fill it on the table. That is the meaning of modulo. And this operation star simply says that if we take any two numbers x and y, we should take the first number, raise it to the power the second number, then we divide that answer by 5 and we take the remainder and fill on the table. That is the meaning of x star y equals to x power y modulo 5. For instance, let's take an example of 1 star 1. So the first number is x, which is 1, star the second number 1. So we should take 1, raise it to the power 1, and then we should perform modulo 5. Modulo 5 simply means we should take the answer, divide by 5, and we take the remainder. So 1 star 1 will simply be 1 power 1, which is 1, divided by 5, which is 0, remainder 1. And the remainder is what we are concerned with, which gives us 1 on this entry. So this is how we are going to fill the table for the remaining entry. Let's take another number that is greater than what number are we going to take? That is greater than 5. Let's take, for instance, 3 star 2. 3 star 2 is simply 3 squared, because we have said x power y. So the very first number is x, the second number is 2. So 3 power 2 is 9. 9 divided by 5 is 1, remainder 4. So the remainder is 4. So 3 star 2 is 4, because we are dealing with modulo 5. So guys, that's how we do questions like this. I'm going to show you a little trick on how to easily get the remainders when we are dealing with larger numbers. So before we continue, if you are a returning subscriber, thank you for your love. If you have not yet subscribed to my channel, don't forget to hit the notification bell, subscribe, like my video, and share these videos. Don't as well forget to comment on the comment section with videos you want us to make videos on, questions you want us to make videos on. Without wasting much of your time, let's dive into the question proper. The first section says that we should complete the table that is given to us. So let's complete this table. And the first entry we are going to be handling here is this entry here, which is 1 star 2. So the first number is 1 and the second number is 2. So x is 1, y is 2. So 1 power 2, which is 1 times 1, which is 1, modulo 5 will simply be 0, remainder 1. So that entry will have a value of 1. The next entry is here. 4 power 2 is 4 times 4, which is 16. 16 divided by 5, modulo 5, is 3, remainder 1. So that entry there is 1 as well. But how do we get these remainders? Let me show you a small trick using a calculator. So I will pull up my calculator here, and we are concerned with 4 power 2 modulo 5. So 4 power of 4, which is 4 power 2, it will give us a value of 16. Now we are going to take this 16, we divide by 5 because we are dealing with modulo 5. So if we divide by 5, what's the result that we have? We have 3.2, but the remainder is not 0.2. So how do we get the remainder in numbers? So I'm going to take all of this value 3.2 and subtract the whole number. What is the whole number? 3. So I'll subtract the whole number from it. So I'll say 3.2 minus 3 so that I get the fraction. It will give me the decimal number, which is 0.2. Now I'm going to take this decimal number and multiply it by the modulo we are looking for, which is mod 5. So I'm going to multiply that decimal number by 5 and it will give me the remainder, and that's the remainder we are talking about, a remainder of 1. So we'll go back to our question, which says that we are going to fill here 1 power 3, 1 star 3, 1 power 3, which is 1 modulo 5. Since 1 is not up to 5, the remainder will always be 0 remainder, that number, which is 1. So we'll have 1 there. We'll have 2 power 3. 2 power 3 is 8. Modulo 5 is 8. Modulo 5 is 3. If you don't know how we get it, we'll come again to our calculator for those who did not follow the first time. So 2 power 3 will give us 8. 8. Now what mode are we working on? We are working on mode 5. So we'll divide that 8 by 5. We have 1.6. So we are going to subtract 1 from that 1.6 because we need to remove the whole number to be left with the decimal part of it. So that 1.6 minus the whole number, which is 1, will give us 0.6. This 0.6, to get the real remainder, we are going to multiply the 0.6 times the mode we are working on, which is mode 5, equals to 3. So the remainder will be remainder 3. Okay, the next number we are going to look for is this space here, 3 power 4. 3 power 4 is nothing but so we are going to use our calculator again. Let me punch maybe for the last time. 3 power 4 equals to 81. 81 divided by 5, because we are working on mode 5, 16.2. 16.2, we are going to remove the whole number. What is the whole number? You are right, 16. So 16.2 minus 16 will give us 0.2, and then to get the remainder we'll take 0.2 times the mode we are working on, mode 5, equals to 1. So that part there will be 1. So that's how we fill the table. That's how we perform modulo. Modulo simply means we are concerned with the remainder. That's how we use our calculator to get the remainders when we are working with modulus. Okay, the next part, which is the B part, says that we should give a reason why X star does not form a group. For us to have an operator that forms a group, there are 5 basic conditions that must be fulfilled by that operator. So this operator star, for it to form a group under the set S, we must fulfill 5 operations. The first operation is the operation of the closure. What do we mean by closure? Closure simply means that at any time we take 2 numbers and we perform at the operator that we have been given, the number should be within that group. So at any time we choose any number x and y, we perform x power y modulo 5, the number that we should have should be 1, 2, 3, 4. If we have any other number apart from 1, 2, 3, 4, then we say that set is not closed under the operator star. In this case, let's look at the table. On this table form here, do we have any number other than 1, 2, 3 or 4 on that table? No. So we don't have any other number. Therefore, we say that the set S star is closed under this operation star. The next law we are going to look at is the law of associativity. Associativity simply means if we pick any three numbers A, B or C, then we perform the operation on the first two numbers, we take the result and we perform that operation on the last number. That result should be the same as A star B, A star B star C. So for instance, if we pick any number 1, 2, 3, three numbers, and we perform our operation on the first two number 1 and 2, 1 and 2, 1 star 2 is 1, the result is 1. If we take this number 1 and perform that operation on the third number, which is all of this now is 1 star 3 is 1 star 3 is 1. So we expect that A star B star C should also give us a result of 1. So let's try. We have the three numbers 1, 2, 3. So the last two numbers are 2 and 3. So 2 star 3, what is the result? 2 star 3, we have a result of 3. So our first number was 1. So 1 star 3, is it 1? 1 star 3 is also 1. So that operation star is associative. But even if it wasn't associative, we cannot use it to give the reason for star be not forming a group, because the question says we should assume that this operation is associative. The next operation that we are going to look at is the commutativity law. So for an operation to be commutative under a certain set, if you pick any number A, for instance star B, it should give us B star A. So let's take any number, let's say 1 and 2. So 1 star 2 is 1, should be able to give us 2 star 1, which is not 1. So we say this set is not commutative under the operation star. For instance, if we want to see that something is commutative, let me bring up a group that is commutative. Like addition is commutative because 1 plus 2 is the same as 2 plus 1. Multiplication is commutative because 5 times 4 is the same as 4 times 5. But division is not commutative because 1 divided by 2 is not the same as 2 divided by 1. So in that case, division is not commutative. So that is what we mean here by commutative law. Let's look at this group here. For instance, I bring up a group here that we have here, and we can see that this group is commutative because A star B is B, A star B is B, and B star A is still B. So we can say that operator is commutative over that set. What about associativity? Associativity, if we choose any three elements A, B, C, so A star B is B. So if we take this B and we star it with C, B star C is C. So we have a C. So if we still pick these elements A, B, C, and then we perform first B star C, B star C is C, and if we take this result C and perform A star C, is still C. So we say that this operation is commutative and associative over this set S. And we can also say that this operator or operation is closed over the set S because all the elements formed here are C, A, B, C. So for the sake of this video, we can just end this question here because we have discovered that this set is not commutative. So if it's not commutative, then we can end here for verification. But we won't end here because for further studies we can need these other laws. So the two other laws we are going to look at are the law of the identity element. If we say that the identity element of that set is E, then we expect that if we choose any element A and we perform the operation on that element, with the identity element, it should be the same as the identity element operation that element, and it should give us that element A. What do I mean? If 1 is the identity element, then if I pick any element, let's say 2 star the identity element 1 should be equals to 1 star 2, which should give me 2. So if we look at this table, keenly, we see that none of these elements is an identity element. If you look at it keenly, we don't have any identity element. And one thing I want you to note about identity element, there can only be one identity element in any set. Now, how do we easily identify identity element? Under the identity element, the numbers will repeat itself in that same pattern in which we have. If 1 was the identity element, then under 1 we are going to have 1, 2, 3, 4, and under 1 here we are still going to have 1, 2, 3, 4. For instance, let's see this. A is the identity element of this group. So here we are going to have under A, this A here, we are going to have A, B, C. And under this A here we are going to have A, B, C, because A star is identity element. A star, the identity element A, will give us that element A. B star, the identity element A, will give us that element B. C star, the identity element A, will give us that element C. So we call A the identity element, because if we perform the operation with any element and A, we are going to have that element itself. So the next part we are going to look at, the next law, is the inverse. So if we say that minus A is the inverse of A, then if we perform the operation A star is inverse should be equals to the inverse star A, which will give us the identity element. So the inverse of the elements keep on changing, but the identity element must only be a unique number in the table. So if we don't know the identity element, then we cannot find the inverse. So in this table, since we don't know the identity element does not exist, then we cannot get what? The inverse of the numbers. So in the case of this problem, if they are asking us that what? Give a reason why S star does not form a group. So I can say that since the operation is not commutative under star, then it does not form a group. Or I can say that what? Since there is no identity element, we cannot form what? We cannot call S star a group. So those are the reasons why S star does not form a group. If it's to form a group, then the closure law must be fulfilled, associative law must be fulfilled, commutative law must be fulfilled, identity element must be found, and the inverse of each element must be gotten. So that's how we handle problem on operation. Stay with me and remain blessed. Bye bye.